unknowns in a frame problem, because it allowed us to simplify some members of a frame. Do you remember what that was? Two force members, right? So if I have a member that's connected on 3 spots, what kind of member is that? 3 force member. So that means if there are pins at the ends, I have to put a force X and force Y at both. But if we have a 2 force member, what did we learn? That the force coming from the force at one end and the force at the other end is what? Transmitting axially through the body. So it converted an X and Y force at one end and an XY force at the other end, which is 4 unknowns, to how many unknowns? 1 that's going right through. It's either in compression or it's in tension. It's the same force. So we were able to minimize 4 unknowns and make them 1 unknown because it was a 2 force member. Kyle, is your hand up?
Yeah.
Oh, okay, that's okay. So when we deal with trusses, that's what we're dealing with. We're dealing with all 2 force members. So let's take a look at the truss pages. Let's see. Look at page 270. We're just going to look at some truss pictures. 270. Just take a look at trusses. Or I guess you could also look at the sheet that I handed out also. Here's some pictures of trusses. But trusses are all 2 force members. All the forces, all the connections are on the end. So it makes trusses a little less complicated than frame problems. Okay? So we're going to do some truss problems. And I'm telling you, you already know how to do it. So I have the sheet up here. And we're going to delete this part. Okay, so let's look at all the forces on this. So Sam, we're up to you. What's happening at A? What kind of connection is that? A pin. So we're going to have an X and a Y, right? Isak, what about F? What's happening at F?
So, I mean, there's a pin connecting to like little hinge thing there.
Right, but what's the thing on the
There's
bottom
just like
of that
a
pin?
normal force.
It's just the normal force. Do you want me to explain again, or explain why? Look at this. If I only analyze this connection, what do I have on it? I have a normal here. And what do I have at the pin? What is it, X or A or B? F. I have an FX and an FY. Well, in the end, what is FX? 0. So it's not really there. So what is FY? It's going to be the normal. So when I wind up drawing this truss, what am I going to draw? Just the normal. We've done this before. We're just transferring the load through the connection up to here. Does that make sense? Enrique?
Would we still count FX as an unknown?
No,
No?
because it's kind of like the problems at the beginning where we have a tension and we have a weight on here, and we said we're not drawing these free body diagrams. We have this big thing here, right, that's connected. We decided that's all we're doing is we're putting W.
Okay.
Right, we just transfer it. It's the same thing. So when I have a connection that has a pin and a roller, that's all I'm doing on the body is I'm just putting in the normal. Isak?
So the rollers to eliminate friction?
Say it again?
The rollers on the bottom of F are to eliminate friction.
Actually,
Sliding.
it's making it a determinant problem. Because this is a 2D body, right?
Mm-hmm.
In trusses, we're not dealing with friction at all, so no friction. Should we write that down somewhere? No friction. So if I took this whole structure away from the main supports, how many unknowns do I have here, Esau?
2,
Right, and how many do I have here?
3.
No,
No,
we
2.
just finished saying that we're transmitting the normal through, right? So it's just the normal. So we have 3 unknowns and it's a 2D body. Can I solve it? With what equations? Some of the forces in the x, some of the forces in the y, and some of the moments. If this was a pin connection and this was a pin connection, how many unknowns would I have? 4. Can I solve it? No, because I don't have 4 equations. I can't do it. There's only one whole body there. So in that case, it's an indeterminate problem. I can't solve it. So it's structurally, that's why they put a pin and a roller. Okay, so let's draw this then. We said that there is a pin connection here at AX. Oops, AY. And there's an AX. And then here's my normal. And now let's look at the problem. It says determine the forces. I added this on, so we're going to look at this a little bit later. They want us to determine the forces in members CD, CF, and FG. How many members are here? Daniel, how many members are in this truss? Remember, they're all 2 force members, so each one, A to B is 1 member, B to C is 1. Nick and Nicholas, can you be quiet? So A to B is 1 member, B to C is 1 member.
I think 12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got 13? 13? Okay, so there are 13 members in here. And because, Eugene, because it's a truss and these are all 2 force members, what's the force like inside AB? Is AB a 2 force member?
Yeah.
Yeah, so what does that mean? Where's the force of AB? David?
Is it 1,000?
Hmm?
1,000?
Well, no, there's an external load here, but isn't it all axially, right? Because these are 2 force members, the force is transmitted inside these things. And they're either being pushed, compressed, or they're being pulled, right? So how many, Larson, how many loads then are in all these inside these things?
In each one,
Yeah,
2. In each bar.
well, it's either being compressed or pulled, but it's the same unknown, right? If I'm compressing it, it's the same force. So within AB, there's 1 axially loaded force. Within AH, there's 1. So if there are 13 members, how many forces do we have inside? 13. Okay, so let's go back a little. Jose and Jason, stop talking. So we're looking at 2 force members because each one of these members are only connected on the edges. Which means the force that's going inside this truss is either a compression or tension. It's lying along the line of the member itself. So right now, if I took the whole structure off, these guys are still intact, right? So these are all internal forces. If I took this whole structure off, what would be an external force? Kyle? The AX and AY, right? And the normal, and then these 4 right here, right? As long as I keep these intact and I don't break them, I don't separate them, They're all internal forces. But now the question asks us to find out what CD, CF, and GF are. So I want you to talk to the person next to you and figure out what would you do to be able to find out what those three, the values of those three forces inside are.